So on A, it says 8xy, that's our monomial. We need to find the degree of it. When there are two variables, also, what did it say? What do we do with the exponents of both variables?
Sum of both.
What does sum mean? Do you know what sum means?
Just addition to an addition.
Yes, addition. Okay, so we need to know their degrees. Preston, what's the exponent on the x? The exponent on the x. What's the exponent on the x? Well, look. It's right here. What exponent is here? What's the only exponent allowed to be invisible? Right here. Not 0. 1. Which means y's exponent is also 1. That's the only one allowed to be invisible. If it's 0, it would say 0. Okay, so the degree of a monomial, when there are two variables, we add them. 1 plus 1 tells us this is a second degree. Second degree monomial. Okay, I want you to look at part B in your workbook. Those of you who didn't bring your workbooks today, here it is, write it down. Part B in your workbook, Preston. Okay, you're coming back to that seat I assigned you last time. Please move. Please move. Pick up your stuff. Right here's the seat for you. Thank you. From the bottom, part B. Okay, I want you to find the degree of the monomial and hold it up in the air, please. What's the degree of part B? It's monomial. What's the degree of B? You add up the exponents. Thank you for raising your hands. Okay, where's the rest of you? 4 plus 1. So everyone should have a 5 up. So this is a 5th degree. Okay, look at C. C says 11. Okay, there are no variables. Please show me what the degree of this monomial would be. Thank you for holding it up. What's the degree of a monomial with no variables? Hold it up. It said it right here. The degree of a non-zero constant. A constant is a number without a variable. Junior, read that last sentence, please, in the blue box. The degree of a non-zero constant is 0.0. The degree of a non-zero constant is 0.0 is not what it says, though. That's just a period after the end of the sentence. I just need the last word of the sentence. The degree of a non-zero constant is, it tells you the number. What's the number? Just 0. So this would be, thanks to those who actually held it up and put 0. Okay, flip over your book to, this was your homework, so I'm just hitting the parts that might have been a little tricky. We're going to look at page 641 underneath problem 3. Page 641 underneath problem 3. Classifying the polynomials. Oops. See if it wants to move. Problem 3, part A, gives us the following. And it asks you to write it in standard form. Once again, there is a blue box nearby that tells us what standard form is. Take a look at the workbook. Raise your hand when you find the definition of standard form. Raise your hand when you know the definition of standard form. Thanks for raising your hand. We got 1, 2, 3. Standard form. You have to flip to the right page, guys. Please, right here. We're right here on problem 3. There are blue boxes next to it. Can you see standard form? Standard form. In the blue boxes, there's 2 pages. There are 2 blue boxes. One of those blue boxes says standard form in bold. Okay, this half of the room, I really don't see very many hands. There's like 2 out of 15 of you. What are we doing? I think I've asked the question 10 times. We're looking for the blue box that gives us information about what standard form is. We need the definition of standard form. There's a blue box up here, and there's one down here. Can you see where it says standard form in dark blue letters?
Yeah.
Okay, Gerardo, it's Gerardo, right? Okay, why don't you read that nice and loud, please? Thanks, everyone, for raising your hands. Standard form of a polynomial. What?
Wait.
So standard form of a polynomial.
Okay, from there.
Uh-huh.
You know what? In the standard form of a polynomial being the degree of a nomial term being from left to right.
Okay, those last 5 words are the most important, so say them again nice and loud.
Decrease from left.
Decrease from left to right. The exponent should be decreasing from left to right. That's how standard form is. Okay, Tristan S. Which term up here has the highest exponent? Oh, good. So, and it's positive because it says plus in front of the 8. So, standard form would start with 8x squared. Now we look for, this is x squared, we need to decrease. Look for x to the first power. That would be the next one in line. X to the first power. Gabe, do we have any x to the first power terms? 2x. Good. And that's positive 2x, so we put plus 2x. Okay, after 2x, Annabelle, what would come next? We've done 8x squared plus 2x minus 3. Good. Because minus 3 is actually x to the 0. X to the 0 is a 1, so we don't write it because 1 times minus 3 is still just negative 3. It doesn't change. Okay, are there any questions of writing standard form? Okay, there was a second part to this question that said, then name the polynomial based on its degree and number of terms. Okay, in this blue box, we have the names of the number of terms. It could be a monomial. Monomial means 1. Binomial, like in a bicycle. Bicycle has 2 wheels, so that would be a binomial. Tricycle, 3 wheels, so a trinomial. And anything more than 3, we stop saying like fourth-omial or quadromial. We don't say that. So we just call them all polynomials. So it goes to poly. Okay, so what would this be? What's the degree and the number of terms? Let's start with degree. The highest exponent. Lorena, what's the highest exponent for this problem? What's the highest exponent? What's the highest exponent? The problem I'm pointing to. What? Okay, so I just need the number. 2. So that means it's a second degree. Are you staying? What's the consensus? Okay, then pull out your workbook, please. You're on page 641. Okay, now we need to decide, is this a monomial, binomial, trinomial, or something larger that we just call a polynomial? Carlos, what is this? Monomial, binomial, trinomial, or a polynomial because it's 4 or more terms? And those words I keep saying are in your book right here in the chart on page 641. What are you saying, Carlos? Trinomial, good, because there are 3 terms. 1, 2, 3. So this is a second degree trinomial. That is the second part of the answer. Second degree trinomial. Okay, so you can write in the book. Okay, the last one I wanted to look at, this was your homework, so I'm not doing all of them, was practice A, number 5. So just at the bottom of the same page, number 5. Okay, it has the same 2 questions. The first question is, write the polynomial in standard form. Write the polynomial in standard form. Evelyn, standard form, we should be decreasing exponents, right? So we have to find our highest exponent. So what term has the highest exponent, Evelyn? Okay, negative 13x squared, not just 13, right? Okay, is there anything higher than that? Or is there something that ties it? Yeah, we have a tie. So to put it in standard form, we're going to combine the like terms. So we need to do 6 minus 13. Preston, what's 6 minus 13?
What?
What's 6 minus 13?
You want me to answer that?
Yes, please. 6 minus 13. Please figure it out. It's the same as negative 13 plus 6. It's the same. What? No. So here's a number line. Here's a number line. Zero's in the middle. 1, 2, 3, 4, 5. Here's 6. 1, 2, 3, 4, 5. 1, 2, 3. Okay, if we're at 6 and we are minusing 13, which direction do we jump? To minus. Good, so we go 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What number is that? Negative 3 is right here. There you go, negative 7. Thank you. Negative 7x squared. Does that make sense? Okay, so you can always draw number lines if those help you. Okay, and then let's copy the rest down. And now we need to put it in standard form. Braden, we need standard form to be decreasing exponents. So what would standard form be? Yeah, good job. That's already in standard form, right? X squared, x to the first, no variable, which is actually x to the 0. Any questions about standard form? Okay, that's the next one. What's the degree? The degree just goes off of the highest exponent. So it's not third, it would be second degree. And then how many terms? 3, and we call that what type of polynomial for 3? Trinomial. Good job. Trinomial. Okay, that should get you going on that. All right, we are going to start a worksheet practicing more adding and subtracting polynomials. This is actually your homework, so we're doing your homework together.